Halt! Who goes there? A burgeoning mathematician with a newfound passion for solving absolute value equations, you say? Well, in that case, come right on in. Hi, friends, how you doing? Today, let's continue our discussion from last time. We're going to pick up where we left off, talking about solving absolute value equations and see how, just like many of the equations and inequalities we've solved without absolute value, we can sometimes end up with some funky, quote-unquote, absolute value equations. So the title of our lesson today, Class 2, Unit 3, let's talk about some funky absolute value equations. Not only do they look a little wonkier than the standard fare ones we saw last time, but that can also sometimes lead us to some funky solution sets. For example, take a look at this guy. The absolute value of 3m minus 1 is equal to negative 5. Now, immediately alarm bells should be going off for you. Why is that? What about this is weird? What's funky? 10 seconds, pause the video. Go. Alrighty, well, hopefully you caught it. If I'm talking about absolute value, by definition, we know that absolute value is positive. So looking at this thing, the weird thing is that on the other side of my equal sign, I see a negative 5. But absolute value is positive, which means that absolute value can't be negative. So what do you think that tells me about this equation? I'm saying that absolute value is a negative number, but that can't possibly be true. What does this maybe mean for my equation? What did it mean in the past when I got something that wasn't true? 5, 4, 3, 2, 7 million. Well, if I've got a statement here like this, I know that absolute value can't be negative. Nothing can make absolute value a negative. This is false. And because this is a fundamentally false statement, nothing can make it true. This equation would have no solution. So I'd say this is a no solution case. If you'd like, you can again use your abbreviation, your circle, with a strike through. Do you remember what the graph of no solution looks like? If not, take 10 seconds, look back in your notes. Well, on my number line, so I should probably start by giving myself a number line. I'll label it with the variable m. Remember, the number line collects the solutions, but here there are no solutions to collect. My graph is an empty number line. Set builder and interval notation we can talk about as well. You remember them? Take 30 seconds, see if you do. Okay, well, the set builder notation for this always begins with the squiggle, but there's nothing in my solution set, so there's nothing in my squiggle. Or alternatively, if you would rather, you can just use your no solution symbol, your empty set. Interval notation, remember it's a weird one because I don't really have any intervals to read on the number line. I didn't color anything in. So I usually say that interval notation does not exist. But if you want to, technically, remember we talked about that weird notation. I could use 0, 0 with parentheses on both sides. So right, I'm starting and ending in 0, so 0 is the only thing. But it's not actually in the solution set, so it gets parentheses. Or, an even simpler way to write that, I could just write 0 itself. In parentheses, that works too. Cool. So I know that no solution is a possible option for me. Another wrinkle for us to unwrinkle, to iron out, we've only seen equations with variables on one side of the equal sign. But what happens if I have variables on both? So look at this. The absolute value of 4 minus 3y is equal to the absolute value of y. So not only do I have a variable, but an absolute value bar on both sides of the equal sign. I need to be a little strategic about how I'm going to make sense of this. Off to the side, I've given you a simpler case to consider. If two things have the same absolute value, what do you think that means about them? Take 10 seconds, take 30 seconds, take a minute, take as much time as you need. What do you think needs to be true about two things if they have the same absolute value? Okay, well in this case, if the absolute value of A is equal to the absolute value of B, let's say that their absolute value is something like 2. I don't know, pick something arbitrarily. So if the absolute value is 2, then A could be 2, right? That has an absolute value of 2, and B could be 2. They could both be 2. They could also both be negative 2, right? If I take the absolute value of negative 2, they would both have the same absolute value. But it could also be a combination, right? I could say that A is positive 2 and B is negative 2. Those still have the same absolute value, same thing, if I swap them around. So hopefully you've noticed, if two things have the same absolute value, then either they're both the positive or the negative version. So in other words, they're the same, or my other option is they could be, if I've got 2 and negative 2, well, those are opposites. So two things with the same absolute value are either the same or opposites. So algebraically, if I want to think about what that means, what that tells me is if the absolute value of x is equal to the absolute value of y, or the absolute value of A is equal to the absolute value of B. If two things have the same absolute value, then either they are the same, in which case x and y would be equal, or my other option, if they're not the same, they could be opposites. And if they're opposites, well, what do I do to turn a number into its opposite? Well, all I would need to do is multiply it by -1. So I would say x is equal to y, or x is equal to -y. And if you'll notice, I'm just breaking this down into two cases. There's a positive case for the y and a negative case for the y. So really, we actually are doing exactly the same thing as we did last time. I'm just breaking this down into a positive and a negative case. So using this idea, if I see two absolute value bars, I can break it down into a positive case and a negative case. If it's the positive case, they're the same. If it's the negative case, then they're different. So my positive case, right, I could say, well, either they're the same, in which case 4 minus 3y is equal to y itself, right, or positive y. And if they're opposites, then 4 minus 3y would be equal to -y. Exactly the same idea, the only thing that changed here is that I threw some absolute value bars in. But by interrogating the simpler choice, we see that the same choice is being made for the same reason. From here, if you haven't already, give yourself some time to solve it. If you've already got the answer, if you've solved these equations, then don't bother pausing the video. Let's do them together. So again, my goal is to get all of my y's on the same side and then eventually get y's by itself. In this case, the easiest thing to do, I would say, is probably to add 3y to both sides. On the left side, they undo each other, and I'm left with 4 is equal to 4y. Divide both sides by 4 to isolate our variable. We find that y is equal to 1. Or my other option, if 4 minus 3y was -y instead of positive y, same idea, I'll add 3y to both sides. We'd find that 4 is equal to 2y. Dividing both sides by that 2, we'll isolate our y, and we'll find that y is equal to 2. Just to make sure that this idea works for us, let's check. Why not? We haven't checked in a while. To check my work, what do? 5, 4, 3, 2, 7,000. Well, in this case, if I want to check that a number is a solution, I should substitute back into my original equation. So let's take 4 minus 3. Every time I see a y, I'm going to replace it with a 1. And then I want to ask myself, is the left side actually equal to the right? So simplifying the left side, I've got the absolute value of 4 minus 3 times 1, which is 3. 4 minus 3 is 1, and the absolute value of 1 is 1. On the right side, the absolute value of 1 is 1. 1 is equal to 1. This is indeed a solution. Same thing I can do on the right side. So I want to check if 2 is a solution, is the absolute value of 4 minus 3 times 2 equal to the absolute value of 2? Well, on the left, I've got the absolute value of 4 minus 6. 4 minus 6 is -2. Its absolute value is +2. The absolute value of 2 is 2. Are these equal? Yeah, boy. This is a solution. Cool. So we've got our solutions here. In this case, both of them make our equation true. Nice. Let's see what happens if we switch it up a little bit. Let me give you something here that maybe doesn't have an absolute value on the right side, but it's still got variables. Same idea. I want to solve for r. Once I've got that, I want to graph it. And once I've graphed it, I want to write my notations. Give yourself a minute, give yourself 2 minutes, give yourself 3 minutes. Who cares? Set a timer, pause the video, see how far you get. Have fun. Hello, are you there? Did you leave me? Please don't leave me. Everyone leaves me. Okay, so same idea. I've got the absolute value equals 4r. If it ain't broke, don't fix it. I'm going to split this into my two cases. So I've got a positive case and a negative case joined by or. On the positive case, I could say 2r plus 12 is positive 4r. On the left, I could say 2r plus 12 is negative 4r. If 2r plus 12 is equal to positive 4r, so I want to get all of my r's over to the same side, easiest way to do that, I would think here, is to subtract 2r from both sides. We'd find that 12 is equal to 2r, divide both sides by 2, and r is equal to 6. Or, if I think about the equation on the right, so I've got 2r plus 12 is equal to negative 4r. Again, let's subtract 2r from both sides. We want to get all of our r's over to the same side. 12 is going to be equal to negative 6r. Divide both sides by that negative 6. And we find that r is equal to negative 2. Okay, again, to make sure we didn't do anything weird, let's check our work and make sure. So on the left equation, I want to check if I substitute in 6 is 2 times 6 plus 12, its absolute value equal to 4 times 6. So in our absolute value bars, well, I've got 2 times 6, that's 12. 12 plus 12 is 24. The absolute value of 24 is 24. And then on the right, I've got 4 times 6, which is 24. Is 24 equal to 24? Heck yeah. And then on the right, I want to check when I substitute in negative 2. So the absolute value of 2 times negative 2 plus 12, is it equal to 4 times negative 2? So I've got 2 times negative 2. Well, that's negative 4 plus 12. The absolute value of negative 4 plus 12 would be the absolute value of 8, which is 8. 4 times negative 2 is negative 8. Is 8 equal to negative 8? No, 8 is not equal to negative 8. So something weird has happened here. I've arrived at a place where I didn't do any math incorrectly, but the answer to this question, right, it in fact does not answer my original question, even though no choices that I made were incorrect. So don't panic. This is something that actually happens quite frequently in math. I have a solution to my equation that I identified correctly, but when I plug it back in, it does not make the original equation true. This is an example of what in math is called an extraneous solution. So extraneous, E-X-T-R-A-N-E-O-U-S. This is an extraneous solution. And by definition, an extraneous solution, what that means is that this is a solution to a quote-unquote changed equation. So I made a choice, right? I broke my equation into two parts. And when I did that, it solved one of the parts correctly, but it did not solve the original equation correctly. So an extraneous solution makes the changed equation true, but it does not solve the original equation. So in this case, what that tells me, negative 2 is not a solution to the equation. I identified it correctly, but when I substituted it back in, it did not make my original equation true. So it gets omitted or left out from my solution set. So now the only thing in my solution set, weirdly enough, is going to be this 6. So I'll graph it on the number line, right? I've got 5, I've got 7. I could keep going off if I wanted to. 6 is the only thing in my solution set. It's in the solution set, so it gets a closed circle. And then on my number line, right, maybe I'll label my variables of R. The set builder notation for this, I'll use my shorthand. Again, remember, I start with a squiggle, and I could write R such that R is equal to 6. That's my only criteria. Or I could just say, in my solution set, the only element, the only thing in it, is 6. My interval notation, again, there's not really an interval. The only thing on my number line that I've shaded in is 6. It has a closed circle, so it gets some brackets. Fantastic. So the thing about extraneous solutions that's now a little bit annoying, it tells us that every time that we solve an absolute value equation, we should always get in the habit of checking our work to make sure that we don't have a solution that's extraneous. Cool. With that in mind, let's do one more for the road, and then I'll give you 2 to consider as a warm-up for the future. The absolute value of 3q plus 7 is equal to the absolute value of 5 plus 3q. I've combined both things, right? I've got a variable on both sides, and now I have absolute value bars on both sides. Let's see what happens here. I want to break this down into my 2 cases. I want to check to make sure I don't have any extraneous solutions. I want to plot on my number line and write my notations. Give yourself 3 minutes, see how far you get. Have fun. Okie dokie, let's do it. So I'm going to break this down first of all, right? My absolute values are by themselves, so I'm going to split this into my positive case and my negative case. If they're positive, in which case they're the same, I would say 3q plus 7 is equal to 5 plus 3q, or my other option, 3q plus 7 could be negative 5 plus 3q. To make sure that I'm negativing the entire 5 plus 3q, right? I don't want just the negative 5. I don't want just the negative 3q. The entire right side needs to be negatived. I'm going to use some parentheses. On the left, again, I want to get q by itself. Well, I need to subtract 3q from both sides, but when I do that, they both cancel out. So I'm left with 7 is equal to 5. This is a no solutions case. So it's possible that I could have no solutions. Let's check the other side to make sure. Well, I've got 3q plus 7 equals negative 5 plus 3q. First thing I probably want to do is get rid of those parentheses. So I'll distribute my negative sign. I've got 3q plus 7 is equal to negative 5 minus 3q. Here, maybe I'll add 3q to both sides, and notice this isn't actually going to give me a problem. It undoes it on the right, and on the left, I've got 6q plus 7 equals negative 5. Now I'm in familiar territory. Want to get q by itself? Let's start by subtracting 7 from both sides. 6q is equal to negative 12. Divide both sides by 6, and we'll find that q is equal to negative 2. Again, there's the risk that this could be extraneous. Let's quickly check and make sure. So when I plug in negative 2, I would get that the absolute value of 3 times negative 2 plus 7, I want to see, is it equal to the absolute value of 5 plus 3 times negative 2? So 3 times negative 2 here, this is negative 6 plus 7. Negative 6 plus 7, don't you dare say anything, is 1. And the absolute value of 1 is 1. On the right side, I've got the absolute value of 5 plus negative 6. 5 plus negative 6 is the same as 5 minus 6, which is negative 1. The absolute value of negative 1 is 1. 1 is equal to 1. This is a solution. So on my number line, I have a single solution to this absolute value equation. The only thing I need there is the negative 2. Again, I'll give myself some tick marks to indicate some scale. I've got negative 1 to the right, negative 3 to the left. Use my ellipses to indicate I keep going. Negative 2 is in the solution set. It gets a closed circle. Don't have anything to the left or to the right. My set builder notation, it will just be the negative 2 in my squiggles, right? That's the only element of my solution set. Same thing for my interval notation. Only thing on my number line is the -2. It has a closed circle, so it gets some brackets. Fantastic. So with all of this in mind, again, with more time, we'd do these together, but I want to make sure that I'm giving you some shorter videos. So these will be our warm-ups the next time that we see each other. If you'd like to get a head start on them now, be my guest. If you would like to not get a head start on them now, you can still be my guest, but I might have some choice words to say to you. I'm kidding. Have fun. If you would like to solve these again, feel free. No obligation. I will see you when I see you. Have a lovely rest of your day. Take care. Be good. Goodbye.